I'm going to start off Objective 2 with a look at the unit circle. Now, some of your teachers may have already introduced this to you. Some might not have introduced it to you yet. But I'm just going to start looking at the parts that we need to know right now. We're not going to complete the entire unit circle right now because there are parts about it you don't need to know about right now. I will do some of the easier degrees first of all. We have to understand that the unit circle has a radius of 1. So each of these black lines represent a radius in the circle, and they have a distance of 1. So that makes this point right here 1, 0. Now, we also know what this is in degrees. It's 0 degrees. Now let's start going around let's go up here, the next one. We know the ordered pair would be 0, 1. If in fact this black radius has a unit measure of 1, this would be 0, 1, and this would be 90 degrees. Over here, it would be negative 1, 0, and it would be 180 degrees. Down here, the point would be 0, negative 1, and it would be 270 degrees. And then we come back here, and not only is this 0, but you could also call this 360 if you want, because you've now gone all the way around. Now, what about the in-betweens? Well, remember in Objective 1, we looked at the special right triangles. 30, 40, 30, 60, 90, 45, 45, 90. Well, this is the 30-degree special right triangle right here. So we're going to put 30 right there. This is the 45-degree angle right here. And this is the 60-degree angle. So you can see the progression, 30, 45, 60, up to 90. Now, we could keep going this way if we want. Or we could go from the 180 right here and work backwards, because you see how this is a 30-degree angle right here? Well, this is somewhat of a 30-degree angle too. You're going to learn it as a reference angle. But it's 30 degrees short of the 180. So 180 minus 30 is 150. So this would be 150. This would be 135. And this would be 120. Now, this is also one of those 30-degree reference angles. But this time it's 30 degrees past the 180. So 180 plus 30 is 210. 45 degrees beyond the 180 is 180 plus 45, which would be 225. This one would be the 60 degrees beyond the 180. So 180 plus 60 degrees is 240. That takes us to our 270 right down here. And now we can do these angles the same way we did this one. We could think of this as 360 all the way around, but this yellow line right here represents the 30-degree angle, which means we didn't quite make it all the way around to 360. So it would be 360 minus 30, which is 330. This one would be 360 all the way around minus the 45 degrees because we didn't make it all the way around. So that's 315 degrees. This one would again be, think of going all the way around, which is 360 degrees, but we didn't make it all the way around. We only made it to right here, which is 60 degrees short of 360. So this would be a 300-degree angle. So now we've filled out all the angles in the unit circle that are measured in degrees. Now, the last thing we have to do is go back and look at something we did in Objective 1, toward the end of Objective 1. Remember, our normal 30, 60, 90 triangle goes 1, 2, square root 3. But we wanted that hypotenuse to represent the radius of the unit circle. We wanted the hypotenuse to be the 1 right there. So we had to divide everything by 2, and we got these values. Now, those values are going to help us figure out what is this ordered pair right here. Well, what's the x value of that ordered pair? In order to get to that point, you have to go over root 3 over 2. So that would be the x, square root 3 over 2. But then you have to go up 1/2, so that would be the y, 1/2. So that takes care of the 30. Now, I did the same thing with the 45. If we lay the 45, 90 triangle in the unit circle, it does something like that. And it's the hypotenuse that we wanted to have a value of 1 because it's the hypotenuse that represents the radius, and the radius is 1 always in the unit circle. The unit circle has a radius of 1. So, what is the ordered pair of that point right there? Well, in order to get to that point, you have to go over root 2 over root 2 over 2. But you also have to go up root 2 over 2. So those are your x and y coordinates of the ordered pair. Now comes the 60-degree angle. So we're going to overlay that 60-degree triangle in the unit circle. And again, it's the radius that has a measurement of 1. So what is that point right there? I'm trying to get it to line up. There we go. So in order to get to that point right there, you have to go over 1/2. So that's the x coordinate, 1/2. And you have to go up root 3 over 2. So that's the y coordinate, root 3 over 2. And that's how we get those ordered pairs right there. Now, you notice I've only done those ordered pairs for quadrant 1. Well, think of all the other, let's go back to the 30 degrees right now, right here. Think of all the other 30-degree triangles that are in this unit circle. I've color-coded to where all you have to do is go back to the origin and then go follow the same color back, and there's another 30-degree triangle right here. The only thing is it's facing in a different direction. So all that does is it changes the signs of these ordered pairs. Okay. Now we're in quadrant 2, and in quadrant 2 the x's are negative, but the y's are positive. Every single point in quadrant 2 has negative x's, but positive y's. So you use the exact same ordered pairs, but you make sure the x's are negative and the y's are positive. Now, once you get into quadrant 3 down here, the characteristics of every single point in quadrant 3 are not only are the x's negative, but the y's are negative also. So you still follow the same color to indicate the same triangle. Okay, in quadrant 1, here's a 30-degree triangle right here. But in quadrant 3, here's a 30-degree triangle right here. So it's the exact same ordered pairs. It's just the x and the y coordinates are negative. Now let's go down to quadrant 4. Every single point in quadrant 4 has a certain characteristic. The x values are positive, y values are negative. So really, if you know everything you need to know about quadrant 1, you actually know all the different ordered pairs in the entire unit circle. So theoretically, you really only need to know quadrant 1, and then it's just a matter of adjusting the signs of the ordered pairs to match with the x's and the y's as to what's positive and what's negative. And hopefully that's a little introduction to the unit circle, and now I'll get on to the rest of Objective 2. Moving on with Objective 2, getting into the actual concepts that are of Objective 2 beyond just the introduction to the unit circle. The first one is the idea of terminating rays and reference angles. There are 3 key ideas that I've mapped out right here. You know the first one because you know the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. And you know that those quadrants go counterclockwise. So when you're dealing with a positive angle, you go counterclockwise. When dealing with a negative angle, you go clockwise. But the whole idea of where the terminating ray is and what's the reference angle, these are probably new to you. Now here's the one that's really important more than any of the others. The reference angles are always to the horizontal axis. So the x-axis. So what does that mean? Well, let's take a look at our first example right here. If angle theta is 260 degrees, where is angle theta? Well, it's positive, so we're going to go in the counterclockwise direction. I know I make it past 90. I know I make it past 180, but I also know right down here is 270, and I don't quite make it. So, there's my terminating ray, right there. It's a little bit short of 270 degrees. In fact, how short is it of 270 degrees? It's 10 degrees short. But the reference angle is always from the horizontal axis. This is a vertical axis. So I go back and I look over here. If this is a 10-degree angle right here, then that means this is an 80-degree angle right here. And so my reference angle is 80 degrees, and I'm in quadrant 3. So what seems like some really ugly instructions that have you do a whole lot of things, it really isn't that bad. Let's move on to negative 700 degrees. So I know negative means I'm going to go clockwise. I'm going to start right here at 0. I'm going to make it all the way around because that would be 360 degrees. Now, if I made it all the way around twice, 360 times 2 is 720. Well, I don't quite make it all the way around twice because that would be negative 720. So I fall 20 degrees short. So there's my terminating ray. It's in quadrant 1. And this is a 20-degree angle right here. So my reference is a 20-degree angle, and I'm in quadrant 1. Now the last one. What if we went 480 degrees? What does 480 degrees take us? Well, it's positive, so it'll definitely take us all the way around to 360. And then if I go another 90, 360 plus 90 is 450. So I know I make it to right there. But then I go a little bit past 450. I don't make it all the way, or I don't make it all the way down here. I just go 30 degrees past 450. And there's my terminating ray right there. Remember what I got? I went 360 all the way around plus another 90, which was 450, and then I stopped at 480, which means this is a 30-degree angle right here. But reference angles are always on the horizontal axis. So again, I was on the vertical axis when I passed this. So if this is 30 degrees right here, then this is 60 degrees right here. And the reference angles are always on the horizontal axis. So my reference is 60 degrees, and I'm in quadrant 2. The next concept is, or it could be, kind of a confusing concept, because what we have to do is we have to think of the triangle as being in the unit circle. So if the triangle is in the unit circle, then it definitely has a radius of 1. But in order to work on the problem, we're going to take it out of the unit circle. So let's take a look at this triangle right here. And we're not necessarily saying it's a special right triangle. It's not 30, 60, 90. It's not 45, 45, 90. It's just a regular old triangle sitting here in the unit circle in quadrant 2. Now, we know half of the ordered pair. We know the x-coordinate is negative 5/13. Well, so if we're concentrating on that point, we have to figure out how do we get to that point. We go to the left 5/13, that's why it's negative. I'm going to put 5/13 down there for a second. And then how much do we go up? That's actually what we're trying to figure out. And the unit circle is 1. Well, the way we're going to work with this is we're going to take this triangle out of the unit circle. We're going to blow it back up to its original form. Now, what that means is I have to multiply everything by 13 because of this fraction. All that means is the hypotenuse used to be 13. And this value down here that represents the same as that value used to be 5. So now, all I have is a Pythagorean theorem to work out. A squared plus b squared equals c squared. So that's 25 plus b squared equals 169. B squared equals 144, and therefore b equals 12. So if you remember your Pythagorean triplets, that's going to come in handy a lot. So all that means is this, in its original form, had a height of 12. So now we're going to take that triangle and we're going to place it back into the unit circle again. So in order to put it back into the unit circle, my hypotenuse has to be 1 because that's the radius. And so I'm just going to divide everything back by 13 again. That just puts that back to 5/13. But the one that we didn't know is now 12/13. over 13. And that's my y-coordinate of that point. In order to get to this point, you go left 5 over 13, that's why it's negative, but you go up 12 over 13, and that's positive. Here's another example of the same thing, but this time the triangle has been placed in quadrant 3. Now we need to know some things about every single point that's in quadrant 3, because this is the point we're going to key in on. Every single point in quadrant 3 has a negative x value and a negative y value, so you can see that the y-coordinate is negative 725, and we're going to put that right here. I'm going to put 7 over 25. And the reason I'm not going to make it negative is in the triangle, this is a distance. So we want to know what's the x. So I'm going to put my little question mark right there. And the next thing I'm going to do is I'm going to take this triangle out of the unit circle. I'm going to blow it up and work with it in its original form. Well, what was the original form? I'm going to multiply all three sides by 25, which means the hypotenuse is no longer in the unit circle with a radius of 1. It actually had a length of 25. And this had a length of 7. So now we have to do Pythagorean theorem again to figure out what was this. So 7 squared, a squared plus b squared again equals c squared. So 49 plus b squared equals 625. Subtract 49 from each side and you get 576. Take the square root of 576 and you get 24. So what we just figured out was this missing side is 24. Now, I'm going to put this triangle back into the unit circle. Notice how my reference angles are going to match up. This was 0, 0, reference angle theta. Here's reference angle theta. Here's 0, 0. And by putting it back into the unit circle, all I have to do is divide everything by 25 to get this, the hypotenuse, back equal to a value of 1, a radius of 1. So this distance right here would be 24 over 25. But since I'm going to the left, the x-coordinate is actually negative 24 over 25. The last concept is reviewing trig functions, sine, cosine, and tangent, SOHCAHTOA, with the special right triangles. So you see I've put back those 3 different models I was using in the unit circle. Here's the 30-degree model, the 45-degree model, and the 60-degree model. Now they're all placed as if they were in quadrant 1, so everything's positive, and notice I have the hypotenuse of each triangle equal to 1, so it's been standardized to where it does fit in the unit circle with a radius of 1. Now, if the sine of theta had root 2 over 2, then what is the acute angle for theta? Well, which one of these has a sine value of root 2 over 2? Well, you have to remember sine is opposite over hypotenuse. So, since each one of them has a hypotenuse of 1, you're really just looking for which one of these angles has an opposite value of root 2 over 2. And the answer is this 45-degree angle right here. opposite, root 2 over 2, over hypotenuse, which is 1. So root 2 over 2 over 1 is simply root 2 over 2. So that must be the 45-degree angle. Now, which one of these has a cosine value of root 3 over 2? Okay. Well, cosine is adjacent over hypotenuse. And again, since each hypotenuse has a value of 1, we're really just looking for which one of these has an adjacent value of root 3 over 2. And it happens to be this 30-degree reference angle right here. So the answer would be 30 degrees, okay, because cosine would be adjacent over hypotenuse. So it would be root 3 over 2 over 1. And anything over 1 is simply itself. Now, this one has a little bit more to it. If the tangent value of theta is square root 3, then what is the acute angle? Well, tangent is opposite over adjacent. So the tangent function doesn't have anything to do with the hypotenuse. So we're not looking for just root 3 over 1. But we do find it right here, because the opposite of 60 is root 3 over 2, and the adjacent to 60 is 1/2. So if we did this, root 3 over 2 over 1/2. There's your opposite. There's your adjacent. Remember what dividing fractions really is. If we want to change it from vertical division to horizontal, it would look like this. Root 3 over 2, we would change division to multiplication, and that second fraction would flip, and then my 2's would cancel each other, and I would be left with root 3, or root 3 over 1. So that tells me that it's the 60-degree special right triangle that has a tangent value of root 3.